Hello everyone, welcome to EcoSense. Save Earth, Save Life. Let me introduce you to my team. There's myself, Darren, Mirza, Teddy, Rifano, Kenrick, and Kenji. Research from NASA reported that over 95% of our activities over the past 50 years have warmed our planet and increased the temperature of the whole planet. And if we do nothing, we will have another 11 degrees increase by the end of the 21st century. However, we have seen some positive action from the community, such as the trend of planting trees as a positive idea for the community. How does a mobile application aid in raising public awareness toward the environment? Introducing EcoSense. EcoSense is a mobile application designed to increase public awareness toward the environment. We aim to amplify positive environmental action by being the connector between campaign initiators and the society while also supporting a green lifestyle.
Our first main feature is the gamified environmental campaign. You can participate in campaigns to make a direct contribution in various environmental issues. In order to make you feel more motivated in completing the campaign, you will be rewarded experience points if you can complete the campaign before the deadline. How exciting! To create a big impact in the world, you can start from small actions. You can contribute to the environment around your home. That's why we also bring in the plant disease recognition feature, which will be able to recognize 38 different plant diseases.
The EcoSense web application has a beautiful homepage. The main dashboard gives you a brief overview of campaign data. The campaign page gives you full control of managing your campaign. The data page gives you more detailed information about your campaign participant. The profile page is where you can view and alter your profile. So let us give you a quick demo of our app.
I'm going to walk you through our Android app. The first screen you're going to see is the authentication screen. You can use your email or Google account to log in or sign up. You can also reset your password in case you forgot it. Okay, now I'm going to log in using my Google account. Our app consists of two major parts, campaign and disease recognition feature. Let's see the campaign feature first. This is the dashboard screen. If you already joined a campaign, you will see your ongoing tasks here. You can also discover new campaigns by browsing through the categories. Let's go back to the dashboard and finish the ongoing task. Click on the task and the campaign details screen will be shown. Here I have completed several tasks before. Let's scroll down and find the uncompleted task. Some tasks require you to upload a proof picture. For this task, the instruction is to pack drinks in a thermos or reusable bottle. Click submit. Because this is the last task of the campaign, completing this task also finishes the campaign. After finishing a campaign, you will get experience points, which we can see on the profile screen. And we can also see the completed campaign's history here. The second part of the app is the plant disease recognition feature. Simply point your camera at a plant leaf. What I have here with me is a tomato leaf with a disease called late blight. You can save the result to learn later, or click on the learn more to see the detail right away. I'm gonna save this for now. You can click on the top right icon button to see your saved items. Click on one of the items to learn more. Okay, so that's it for the app demonstration.
Now let me show you a quick demo of our web application. We have a beautiful homepage that gives you some information about EcoSense and the features. If you feel that it is too bright, no worries, because it supports dark mode. How beautiful it is. You can log into the dashboard or sign up if you don't have an account. Now let's try to log in to our dashboard. Let's wait for a while. Okay, the main dashboard gives you a brief overview of campaign data and statistics. The campaigns page gives you full control of managing your campaigns, such as adding new campaigns, editing or deleting campaigns. The data page gives you more detailed information about your campaign's participants, including daily participant registrations and completed task proofs. And the profile page is where you can view and alter your profile.
This is our roadmap, which starts by working together with strategic partners in July, fundraising in August, then expansion in September, alpha testing in October, pilot launch in November, and ends with mass user acquisition in December.
Okay, that's been it for our capstone project. EcoSense,
Save Earth, Save Lives.
Hello, everyone. Good afternoon. Welcome to Bangkit 2022 guest speaker sessions. How's your day? This is the first day of July, and I hope it will be great. For me, I'm very excited because this is my first time being a moderator in Bangkit guest speaker sessions. I hope all of you are excited to learn and discuss together. Before we start session, you can fill out the chat box to say hello and spread your positive energy to the others. Say hello. Let me introduce myself. My name is Thomas Ken Ronaldi. People usually call me Ken, and it's a pleasure to be here with you today. I'm a graduate of Bangkit 2021 machine learning students. I also want to thank everyone for attending and for Bangkit team for preparing this guest speaker session. Today's topic is very interesting, especially for all of you from the machine learning path, since we will talk about artificial intelligence breakthrough in competitive programming. And for today, we have Kak Adhi Kuncoro as a speaker. Please welcome.
Hello, everyone.
Hello, Kak Adhi.
Hi.
Where are you now?
London.
How's London today?
It's good, sunny.
Yeah,
It's 9:30 a.m. in the morning.
yeah, and then a little bit summer, right? Is
Yeah,
it
it's summer.
London is summer? Yeah,
That's right.
in Indonesia is summer too.
It's always summer.
Yeah. Let me introduce Kadi. Kadi is a senior research scientist at Google DeepMind in London. He has been involved in some artificial research projects at NARA Institute of Science and Technology, University of Washington, and Carnegie Mellon University. And he also had internship in Accenture and the World Bank. It's an honor for me to be with you and also a precious opportunity to learn with Kadi. Before we start our session, please take notes and pay attention to Kadi since this is a very rare opportunity to learning with him. If you have any questions throughout the presentation or other questions for Kadi, feel free to put them in YouTube chat and we will discuss them together. Don't forget, this is not the mandatory session and you can fill the form, the registration form on the description below. That's all for introduction. Kadi, the stage is yours.
Right. Okay. Yeah. Thank you, Ken. And hi everyone. I'm very pleased to be here today. Thank you for the invitation. So let me share my screen. Right. Okay. So can everyone see it? Let me turn off this. Okay. All good? Okay, cool. Yeah, so let's get started then. Hi everyone. Again, I'm Adhi. Thank you again for the introduction, and thank you all for watching. And thank you for the Bangkit organizers for inviting me. I'm very excited to be here today to talk about an overview of deep learning, which is a type of machine learning that has been very successful recently. And I'll talk about AlphaCode as well, which is a recent AI breakthrough from my company, DeepMind, that makes artificial intelligence that can do competitive programming, which is a really difficult problem even for us humans, right? So if computers and AI can do it, then that's a very remarkable breakthrough in the field. So cool, yeah. So let's get started and let's make this interactive. So please be sure to ask questions, and I'm looking forward to discussing more with you. All right, so a little bit about me. They can already did an intro, but just briefly, I'm currently a senior research scientist at DeepMind. It's London. I'm based in London, and DeepMind is an AI research company that's also based in London. It's now part of Google's parent company, Alphabet. So it was a startup before, and then DeepMind got acquired by Google and Alphabet in 2014. So we're part of the Alphabet family and a sister company to Google. And we do AI research. We do AI research basically at DeepMind. And I'm also a final year PhD student in computer science at the University of Oxford, where I research machine learning. So, yeah, machine learning and AI are topics that I am very excited about, and I'm very happy to share my knowledge with you today. And I hope it can be useful. And here's a brief bio of my journey in machine learning. So I did my undergrad in informatics engineering at ITB in Indonesia in 2009 to 2013, which was quite a long time ago. And then after ITB, I went to the University of Oxford in England, where I did a master's in computer science, specializing in machine learning as well. And then I did an internship at NARA, Institute of Science and Technology in Japan. And then after that, I did a research master's in Carnegie Mellon, that's in Pittsburgh in the United States. And then I came back to the UK afterwards to do my PhD at Oxford and also work at DeepMind at the same time. So yeah, so you can see it's been quite a long journey for me in machine learning, and I will share with you a bit of what I learned from this journey basically later on in the talk as well. Cool. So we have quite a few topics to cover today. So first is, I think you've had some machine learning classes at the program before, but I'll do a brief overview of AI and machine learning just to refresh your memory. And we'll talk about deep learning, which again is a type of machine learning that has been very successful today. And then I'll talk about some applications of deep learning. And then, well, the key thing that I want to talk about today is AlphaCode, which is how we can use deep learning to do competitive programming. And then I'll talk about deep learning is cool, but what are the limitations of deep learning? Because it's not perfect yet at the moment. So we'll talk a bit about that. And then I'll share some of my thoughts about working at DeepMind, what's special about the culture. And then, I'll talk a bit about my journey in machine learning as well. And everything here is my own views. So it's not necessarily the same as DeepMind's views on the topics, for example. Cool. So let's get started. Right, so what's AI? Well, AI, the simple definition is that AI is a field of study that aims to build intelligent machines that can mimic or even exceed human intelligence. So if we can make, machines that can be as smart as or even smarter than humans, well, that's a form of AI. So for example, can we make computers that can do programming? So it's a bit like self-programming in a way. And that is a type of AI because, well, it takes us a while, right, to learn how to program. It took me years, for example, to learn how to program, or maybe machines that can predict stock market prices because it's difficult, right, to predict stock market prices, or even solve mathematical equations because, we learn mathematics from elementary school all the way to university. So it takes us many years to learn mathematics. And then if there's machines that can solve mathematical equations better than humans can, well, that's a form of AI as well. Even playing chess, writing a thesis. So all these are forms of intelligence, artificial intelligence, if machines can do these things. And it's very much multidisciplinary. So when I work with colleagues with various backgrounds, for example, a lot of people have backgrounds in computer science, some in information engineering, cognitive science, neuroscience as well, which is interesting because we have one example of intelligence that's human intelligence, right? So neuroscience studies the human brain. So how can we make machines that can be as smart as humans? Maybe we should take inspiration from, well, how do human brains do it, right? So neuroscience is a study of the human brain. And mathematics, of course, the underlying theory of machine learning, so mathematics and statistics as well. Philosophy, what does it mean to be intelligent? What does it mean to be conscious, right? So yeah, philosophy as well, psychology. So I work with colleagues from very different backgrounds here at DeepMind, and that's because AI by nature is very much multidisciplinary. So right, that's AI. So what's machine learning? So machine learning is a subfield of AI that aims to design an algorithm that can learn and improve from data. So the way that it works usually is that we as machine learning researchers, we design certain models. So for example, linear regression or neural networks, if we're talking about deep learning, or random forest. Yes, we do these, and then we train the model on data. So we have data, we train the model on data, and then once the training is finished, the model is trained on data. We use the machine learning model to make predictions. And then, so you might have heard of related topics like big data, data science, and other related topics. So they're all very much related to machine learning. Right, so that's what machine learning is, but it's easier for us to look at a concrete example, right? So, for example, there's a chest X-ray scan. You go to a hospital, you get an X-ray scan, and then you get the scan, and then the task is based on the scan, we have to classify, based on the scan of our chest, do we have a normal lungs, or do we have a bacterial pneumonia or viral pneumonia? So if we have pneumonia, then we have to be treated, right? And and we should treat that quickly. So if we can have machine learning models that can, based on the scan, they can predict whether we have pneumonia or we don't have pneumonia. And if we do have pneumonia, what types of pneumonia do we have? Then that can be something that can be potentially life-saving. So imagine that we have lots and lots of human labeled data, for example, 100,000 scans of chest X-ray scans, and the label. So this X-ray scan that's normal, that one has viral pneumonia, and so on and so forth, say 100,000 data points. We're going to train a machine learning model on this, and then once we train the machine learning model, we can give the model new scans, right? And then the task of the model is to make new predictions. This new scan, is it normal or does it have pneumonia? And the reason why we use machine learning is that because it's much faster for machines to make these predictions. So they can classify hundreds, thousands, maybe tens of thousands of such scans in a matter of seconds. Whereas for humans, if we want to classify tens of thousands of X-ray scans with humans, that's going to take quite a while. And it's going to require quite a lot of experts to do this, as you can imagine. Whereas with machine learning, it all can be done very quickly. So that's one of the reasons why we want the machine learning model to be able to do this task. To automate this in a way. Right, so there's three types of machine learning. First one is supervised learning. So the example I showed you was a type of supervised learning. We have the X-ray scan, for example. We have the human labeled data that we're going to train the model on. So the first type, the example before, and the second type is unsupervised learning. So for example, okay, we just have a bunch of data and we don't have human labels for them. So for example, imagine that we're a bank, right? We're a bank, we have, say, millions of customers, and then the task of the machine learning model is to find clusters of the customers. And we want the clusters to be meaningful. For example, one cluster should correspond to maybe, oh, these clusters is homeowners, or that cluster is not yet homeowners, which means that not yet homeowners, what we should sell them as a bank is maybe we should sell them a mortgage, or bahasa Indonesia KPR ya. KPR, kita jual ke mereka KPR gitu. Or another cluster is, for example, okay, that one is employees and that one is small medium enterprise owners, which means that, okay, small medium enterprise, then maybe we can give them credit to expand their business, for example. So this type of unsupervised learning, we just have a bunch of data. We have to find some meaningful cluster from that. That's one example of unsupervised learning. And the third is reinforcement learning. So we learn from reward. So say the reward is minimizing something like energy use because, well, we don't want global warming to be bad, right? We want to minimize global warming as much as possible. So that's the reward signal. We want to minimize energy use, but we still want our house to be at a comfortable temperature, right? We don't want it to be too hot. We don't want it to be too cold, our house. So, okay, we're going to let the machine learning model minimize energy use whilst keeping the house comfortable. For example, okay, the machine can set how much air conditioning is needed at a particular time. Maybe during the day, we need more air conditioning. During the night, then we need less, right? Because the night is colder than the day. And the machine learning model can set that depending on the reward function. Right, next slide. Right, so that's for AI and machine learning. I'm going to talk briefly about deep learning, and this is going to be very brief. So if you have questions later on, please do ask away. Yes, so deep learning is machine learning that's based on neural network models. And so I have two examples of neural network models here. One at the top is a shallow neural network, and the one at the bottom is deep neural networks. And deep learning refers to the deep neural networks here, shown at the bottom here. And right, so what's the difference? Right, so imagine that the task of the deep learning model is to approve loans based on certain features. So the ones shown in red here are the features. So if you want to know, should we give a loan to someone, we should know their income, right? Their income, we should know how much loan value that they're asking. We should know the interest rate. What's the interest rate? What's the loan to value ratio? How long is the term? Is the loan for 1 year? Is it for 2 years? Is it for 10 years? And so on and so forth. So the ones in red here are the features. And the one shown in yellow here is the deep neural network hidden state. And the one shown in blue here is the output. So the output can be, okay, approve the loan or reject the loan. That's going to be the output of the deep learning model in this case. And so shallow neural network means there's only one level of hidden layer. So there's only one layer of the yellow thing here. Whereas for deep neural networks here at the bottom, there's multiple layers of neural network hidden states. So there's, as you can see, there's 1, 2, 3, 4 layers of neural network hidden layers here, which means that the model is deep rather than shallow. And neural networks are loosely inspired by biological neural networks in humans because in our brain, there's lots of connections between different neurons in our brain. So it's inspired by that, loosely inspired by how the human brain works. Right, so why do we need deep learning models? Why are shallow neural network models not enough? So you might already see an automatic, face tagging system, right? Photo tagging system. So if you go to Facebook, for example, and you have a picture, Facebook will suggest, okay, well, you take a picture with your friends. Facebook can already suggest, okay, well, that picture is my friend Bob, for example. That picture is my friend Kate, and so on and so forth. And the way that one of the best performing systems to do that at the moment is using deep learning models shown at the bottom here. They are already showed to you earlier. And the reason why the neural network needs to be deep is that why the network needs to have multiple layers rather than just one layer is that deep neural networks can capture increasing levels of abstraction. So say the first layer here, the one that's closest to the input features, turns out that they can capture pixels. So they capture something very simple, which is that pixel, is it light or is it dark? That's it, something simple, light and dark. But the second layer identifies something more complex, which is edges and shapes. So the first layer just knows about pixels, light or dark. The second layer knows something more complicated, which is okay, what's an edge? What's a line in a way? So from pixel, we go to something more complex, which is a line. And the third layer goes even more complex than a line, and as you can see here, it corresponds to something like a nose or an eye or an ear. That's what third layer does. So they capture beyond just lines and edges to actual objects in the face, like eyes, ears, and so on. And the fourth layer, which in our example here is the last layer, they capture something even more complex, which is a human face. So you can see here, this already looks like human faces. So deep neural networks can learn to combine simple features like pixels, light or dark, to lines, and then lines to objects, and objects to an actual human face. So that's why we need deep neural networks. So they have an easier time doing this than shallow neural networks. Okay, so that's very much overview of deep learning. I'm not going to go too much into the theory, but if you would like to know more, feel free to ask questions. So what are the applications of deep learning? So so one example from DeepMind is the game of Go. So the game of, I'm sure you know chess. So chess has already been solved by computers since the 1990s by something called Deep Blue, but the game of Go is actually a lot harder than chess. And one of the reasons why it's hard is that because there's really a lot of possible moves that you can do in the game. So for example, there's more numbers of possible moves than the number of atoms in the universe. So if you imagine how small an atom is and how big the entire universe is, then yes, so there's more number of moves in the game of Go than in the number of atoms in the universe. And the game of Go has been played by humans for a very long time. So the ancient Chinese have done this game for more than they already played this game more than 2,000 years ago. So there's already a lot of human knowledge in this game that's refined over generations, over more than 2,000 years. A lot of human knowledge, and then one of an artificial intelligence model from DeepMind, the company that I work for, they created something called AlphaGo Zero. So they learn from scratch. So we don't tell the AI anything about the game. So we're not telling them anything about the game, but the game can learn to beat even the strongest humans in only 4 hours of training. So 4 hours of training, 4 hours of AI training can even beat the strongest human whose knowledge has been refined over thousands and thousands of years. So it really is quite remarkable that we have AI that can do this very complex game. And then another one is, as I mentioned before, one of the homeworks of our generation is to minimize global warming, right? And well, climate change is real, it's serious, it's one of the biggest challenges of our generation. And then, well, if you know, well, Google, as you can imagine, they have a lot of data centers because all those Google search, Google Translate, Gmail, all of those need computers, right? All of those need data centers to serve all the requests from everyone around the world. So the question here is that data centers can get very, very hot because there's, I don't know, thousands of computers in there, so it can get very hot. So we need to cool the data center. And cooling a data center requires a lot of energy, as you can imagine. If cooling a house requires a lot of air conditioning, imagine how much energy does it take to cool a data center? The answer is a lot. And so how can we make the data center cool enough, but at the same time consuming the least amount of energy possible? And we can use AI to do that, of course, because it's we should use AI to help us do this. And so we want to minimize energy use whilst keeping the data center cool. And there's an AI from DeepMind can reduce Google data center cooling bill by more than 40%. And so we can save energy by 40%, which is great. Yes, and maybe we can apply the same, someday we can apply the same AI technique to households. For example, how can we keep the house cool in the summer and the house warm enough in the winter? Right? In the UK, the winters are cold, so we need to keep the house warm enough. And then any savings in energy use is really good because that means less, we contribute less towards global warming, which is one of our biggest challenges of our generation. Another recent breakthrough is protein folding. So, proteins underlie our biological processes, and then one of the long-standing challenges in biology is that how can we predict the shape of a protein just based on the amino acid sequences? And then can we do that with AI? Because previously, before this AI came out, it takes researchers months to predict the structure of protein based on they need to do a lot of experiments, which is time consuming and spends a lot of money. So so can we use AI to do that? And it turns out that the answer is that we can. And DeepMind has an AI that can do protein folding without requiring expensive experiments, which takes time, takes researchers time, takes a lot of money. And then the next question is how can we use this AI model to make new medicine, for example, or design new vaccines for something like the next pandemic? Well, we know the COVID pandemic took a big toll, but maybe the next pandemic we can do better and design vaccines quicker because we have AI to help us someday. That will be or design new medicines for diseases. So how can we use this AI to design new medicines? So all those are open questions that maybe AI can help us get there quicker and potentially save more lives. So so the potential of AI is really almost limitless. And lots of other breakthroughs. So, for example, nuclear fusion is controlling nuclear fusion is another one because we need new energy sources. As you know, oil prices are really high at the moment. So how can we make new and renewable energy sources? Because we don't want to make global warming worse than it already is. And nuclear fusion's one way of doing that. And one of DeepMind's AI breakthroughs takes us a step forward towards doing that. And lots of other applications that I'm sure you use every day. So the faces here on the left are not, they look like real pictures of human beings, right? But they're not actually real pictures. So they are actually, they're not photos, they are machine generated pictures. So these are not pictures of humans, but rather these are machine generated pictures. So it's not real. The people here on the left do not actually exist. These are only machine generated ones. But personally, I have a hard time of distinguishing, is this an actual photo of humans or is this machine generated? Frankly, I can't tell the difference anymore these days. So they can generate very realistic looking photos of people. And the one on the right here is the translation system. A lot of people in the world don't speak English, but a lot of the information in the world is in English, right? So how can we make this information that's mostly in English accessible to everyone in the world? And something like Google Translate, which is powered by AI and deep learning, is one way of doing that. And another example is Google Search. So there's a new machine learning model from kind of 3 years ago. It's called BERT. So it's used in Google Search, which is, there's so many Google Search every second, right? And you can see the difference in Google Search quality before and after the model. So, for example, someone asks Google, all right, does a traveler from Brazil to the USA, do they need a visa to go to the USA? That's the question. And before using BERT, the result was wrong in a way because it's about US citizens traveling to Brazil. That's not the question. The question is about people from Brazil traveling to the USA, not about people from the USA traveling to Brazil. So the previous answer was wrong, and now the answer after using the BERT model is right, which is that, okay, tourists traveling to the United States from Brazil require visas. So yes, Brazilians need a visa to go to the USA. So it answers the question, whereas it didn't before. And here's the previous one. So do aestheticians have to stand a lot at work? And then previously the answer was wrong, since that it wasn't related to that. So the answer was about medical esthetician versus spa estheticians, which isn't what the question is about. And after using this machine learning model, it gives us the right query, the right result, which is, okay, if you want to be an esthetician, what's the physical demands of being an esthetician? Another question is, okay, can you get medicine for someone from the pharmacy? So say I'm sick, can my mum take a medicine for me at the pharmacy? And then previously it was wrong, but after using this machine learning model, we get the right answer, which is, can a patient have a friend or a family member pick up a prescription? So yes, and really the remarkable thing about this BERT model is that the original team that made this model, there's only four people who did this research project. So imagine 4 people can make an impact to something as big as Google search, right, which is used by billions of people. So machine learning provides us a way of, a small number of people to make an impact in a lot of people's lives. For example, through making Google search better, which is something very remarkable. Yes, that's an example. Another example of deep learning these days is language generation. So I'll give you a minute to read this article here. Yeah, so you might get a sense from reading this article that, I mean, for me at least personally, I have a hard time guessing whether this is machine generated or human generated, and it is indeed machine generated. So an AI made this article. It's not actually a human who wrote this; it's an AI who wrote this article, which is, yeah, for me, it's already hard to tell whether something's AI generated or human generated, which is also something quite remarkable, right? Okay, so those are some examples of deep learning, and today I'm going to talk specifically more about AlphaCode, which is a recent AI breakthrough from DeepMind, and yes, that I'm excited to share with you today. So, right, okay, so let's go to the AlphaCode slides. Okay, so does anyone have any problem seeing the slides, or is it good? Please say something if you can't see it. Okay, well, I assume everyone can read it. Cool. So I'm going to talk about AlphaCode, which is an AI system that can do competitive programming. And the slides here are made by my brilliant colleague Nando de Freitas and the AlphaCode team. So I'm just reusing their slides. All the credit for the beautiful slides goes to Nando and the AlphaCode team. Right. So you may have read in the news a few months ago that DeepMind makes an AI that can write code. Right. Usually, we have to write code and then test them, but actually, DeepMind AlphaCode is an AI system that can actually write code, and there's a lot of news articles about it. And some says, "Oh, DeepMind invents an AI tool to write new computer codes," and then someone even asked, "Computers can now write their own code." Does this mean that we don't need programmers anymore? Which is, I think, is a very strong take on this. I don't think that's the case. And then, yeah, so yes, so there's a lot of these news articles, but well, maybe one of the most interesting news coverage for AlphaCode is this. So imagine that AlphaCode as a dog speaking mediocre English. That's the analogy. So imagine, there's a dog that can speak English. Is the English good? Well, maybe not very good, but still there's a dog that can speak English. I mean, that's really the remarkable thing. So if anything, AlphaCode is only the beginning, in the sense that hopefully what comes next will be even better than AlphaCode. So, there's a machine that can write programs on its own without human help. I think that's very, very remarkable. And hopefully AI will get even better from now on. And this is the AlphaCode team from DeepMind. This is the brilliant team that made this project happen. basically. Right. So here's an example of a competitive programming. So you are given two strings. One string we call S, another string we call T. And both strings are lowercase English letters. And we're going to type the string S character by character from the first character to the last one. Right. When we type a character, rather than pressing a button, we can press the backspace button. And backspace does backspace, which is deleting the last character you have typed. Right. So for example, S is A, B, C, B, D. Yeah. Right. S is okay. A, B, C, B, D. Right. And if we press backspace instead of the first and the fourth characters, so how does it happen? The first character is A. We're not going to type A. We're going to type backspace, right, for the first character. Okay, we're going to type backspace. Okay. And then second character is B. We're going to type B. Third character is C. We're going to type C. And then fourth character is B, but we're not going to press B because the fourth character, we're going to press backspace instead. Okay, backspace. Let's do backspace. And then the fifth character is D. Okay, so if we press backspace instead of the first and the fourth characters, we're going to end up with BD rather than ABCBD. Right, so that's the example here. And another example is, yeah, there's another example here. I'm not going to do it for time constraint, but yeah, feel free to. So, I mean, you get the gist. So rather than pressing certain characters, you just press backspace instead, and you get a different string, right? And so here's the task. If we have the string T, can we get the string T based on the string S by pressing backspace? Yeah. So can we get from ABCBD to BD by pressing backspace instead of typing some of the characters? And the answer is yes in this case, because, well, yeah, if we press backspace on the first and the fourth characters, then we get BD, right? So for this particular case, the answer is yes. Yeah, so that's the gist of the task, this competitive programming example. And I think it's remarkable that an AI can do this because, I mean, me personally, I did computer science for my undergrad, and I'm really not very good at competitive programming. So if there's an AI that can do this, that's really something mind-blowing to me because I'm not good at competitive programming. So in a way, the AI is already better than me in doing this. Yeah. So all right. So let's go to more detail. Here's the input. So the first line is the number of test cases. It can be from one test case or 100,000 test cases, which is 10 to the power of 5. And then each test case contains a string S. This is the length of S, and each character is a lowercase English letter. And the second line of the test case is the string T. String T, also the same range of length, and then each character is also a lowercase English letter. And then, yeah, to go to the total number of characters does not exceed 2 times 10 to the power of 5. And then the model has to predict that for each test case, can you get T from S by substituting some characters with backspace, as we saw earlier? If we can, the answer is yes. The program has to answer yes or no. So that's the only possible output from the model, yes or no. And for example, here there's 4 test cases. This is the first test case, 1 and 2, first test case. The answer is yes. This is second test case, this and this. Can we get BB from ABABA just by typing backspace? The answer is no. This is the third test case, AAA and AAAA. Can we get to AAA from AAAA by pressing backspace? The answer is no. And this is the fourth test case. And can we get this from this? And the answer is yes. Right, so that's what the program has to output, and our job is to make an AI that can do this. That can do this, that can make a program that can solve this with little human intervention, with no human intervention even. So the machine has to do its own coding without human help. And here's a solution to that problem from AlphaCode, and this is an actual example. So as you can see here, and reading this program to me as also a programmer, it makes sense because, all right, this for statement for I in the range of T, we read the 2 phrases, A and B. All right, so we put S into A, we put T, which is the second input, into B. That makes sense, right? That's something I would do as well. And then we do reverse, right? We reverse this written in Python, by the way. We do reverse A, reverse B, and then there's C. We initialize another list C, and then we do this while loop. That basically what it does is that, yeah, it does this here. If the letters at the end don't match, then the last letter must be deleted. If they match, then we can keep going, basically. Yeah, so this is what this block of code is doing. And then backspace deletes the two letters, right? So which means that we do pop, that's deleting, right, with backspace. And then, yeah, and here's the answer. So if we've matched every letter is possible, means the answer is yes. If we can't match them, the answer is no. So yes, as you can see here, this is, I don't know, to me, I mean, it's a very reasonable program. And maybe if you give me this program without me knowing, then I can't tell the difference. Is this an AI generated program, or is it a human generated program? Because it makes perfect sense to me. Right, so here's there's a visualization that we'll go to it later on. And so how's the performance of this AI model? So on 10 recent contests, AlphaCode ranks on the kind of about at the 50th percentile, which means that it's at the median human performance. So it's at the median contestant performance in 10 recent contests, which means that, yeah, I mean, it's about as good as the average average contestant on 10 most recent contests, which is, yeah, I think it's good, because I mean, if you go to code forces, then likely you are pretty good already at competitive programming. So I think it's remarkable that the model can do this. And among contestants in the last 6 months, AlphaCode's rating is 1,238, which is in the top 28%. Yeah, so among unique contestants in the last 6 months, actually the rank is better. It's in the top third, which means that 70% of humans are actually worse than AlphaCode. Yeah, so that's the performance of the model. So why should we care about competitive programming, right? Why is it an important benchmark to test our AI models on? And there's 4 reasons. The first one is that it tests for language understanding. So to do well in this, you have to understand what is the specification, right? So what is this saying? I mean, you need to understand what this means, all this input and all this output. So the model has to understand human language in order to solve this problem. That's the first reason. And then it's also a nice benchmark to drive research, because there's lots of data sets for training the model. There's GitHub, right, that we can scrape. And yeah, GitHub has so many programs that we can train the model on. There's clearly defined goal in the sense that the metric is clear. Either you get the right answer or you don't, right? There's no ambiguity in the metric. And the correctness evaluation is automatic in the sense that we have the test cases. Do you pass those test cases or not? That's it. So it's an automatic metric. We don't need human to evaluate, okay, how good is the model? We don't need that, because we can test the model in an automatic way. And the metric is reliable in the sense that, yeah, well, I mean, it's reliable. Either the model gets it or the model doesn't, right? Either they get it right or they don't get it right. And it's about programming. If we can have AI that can do programming, then that's something that can be very useful. And then, yes, so if we make progress in competitive programming, then that can advance AI in other domains as well. Yeah. So that's why we should do this benchmark, and it's a cool benchmark to do research on, machine learning research on. Right, so here's the approach of AlphaCode. So we collected data from GitHub. And then, yeah, because GitHub contains a lot of code, right? We want to train our machine learning models on code, because it's a programming problem. Collect data from GitHub for pre-training, and then there's the code contest, which is domain specific, and we use that for fine tuning. So we pre-train the model on GitHub data, which is a lot, but it's not specifically competitive programming. And then we have a smaller data set that's competitive programming, but more kind of in domain, in the sense that there's a problem that we're looking to solve, whereas GitHub is more kind of general purpose programming. And then, right, we train the model, and then we do this sampling and evaluation. I'll talk to this in more detail in a bit, so don't worry if this doesn't make sense just yet. Right, so we pre-train what's called a transformer language model, and a transformer is a deep learning model. We pre-train them on GitHub, which has a lot of data, and then we fine-tune them on a competitive programming data set that's called code contest. And it's not too big, actually, this dataset code contest. There's 13,000 problems for training and 100 for validation and 100 for another 100 thereabouts for testing as well. And the model that we use, the machine learning model, is called a transformer. A transformer is a neural network model. It's the same model that we use for machine translation. So imagine you have a French sentence, this French sentence here, then the task of the model is in translation, they have to output the English version of the same thing, right? But here we're not doing translation. We're doing a transformation from description, okay, what we want the program to do in human language. And then the output is code, which is the code that hopefully does what we ask them to do. So yeah, description to code. That's what the model's doing. And then here's an example of this. So yeah, I'm not going to go into too much detail on this, but please ask questions if you're interested. So we encode this input with an embedding layer, and then we have something called an encoder, which is a transformer neural network layer, and then we're going to predict the first output here, which is the word. If this is the input sentence, what's the first output? The first output is the word I, and then given the previous output, the word I, and this input, we're going to predict the next thing. What's the next thing? It's the word am, right? I. So we predict the output one by one. First we predict I, then we predict am, then we predict then we predict should. So that's the gist of it, which is that we predict the output one word at a time. So I, am, should. So yep, that's how the model works in a way, by generating the output one at a time. And then here's the details of the transformer model. Again, I'm not going to go into too much detail for the purpose of this talk, but please feel free to ask. Yeah, it has a multi-head attention. It has a scaled dot product attention. Yeah, so yes, it's a lot of detail for now, but yeah, feel free to ask if you're interested. Right, so here's the AlphaCode model. So it's the transformer neural network model that I mentioned earlier. It has 40 billion parameters. Yeah, so it has 40 billion parameters, and then the encoder layer. So the encoder is the one here. Encoder is shallow, but the decoder is deep. Yeah, so that's it. Right, so okay, so that's the model, and that's the data set, right? I described the data set earlier. We're going to train that model on the data set. All right, model is trained. What do we do next once the model is trained? And right, so we allow a maximum of 10 submissions per problem, right? So in a way, the AI model gets 10 tries. So okay, the model tries the first program. Does it work or not? If it works, good, the model passes. If it doesn't work, then the model can try its second solution, and then if it also doesn't work, third solution, and so on. If all 10 programs that's the output of the model, all 10 are wrong, then the model fails on that instance. But if any of the 10 works, then we consider the model to be correct. And yeah, so we have two metrics here. One is that, given 10 submissions from K samples, so we pick 10 out of K samples from the model, what's the solve rate? So if any of the 10 is right, then the model gets 100%. If all of the 10 are wrong, then the model gets 0% for that particular instance. And the second metric is pass at K, which is if we allow the model K samples, say 1 million samples, and then we submit all 1 million of them, what's the solve rate, which is an upper bound on the performance of the model. Right, and okay, so what AlphaCode does is that they sample from the sample programs from the model, and then yep. And then, right, so it depends how many samples do you take, right? I mean, from the neural network model, how many samples do you take? Do you take just 1 sample, 10 samples, or 100 samples, or 1,000 samples, or even 1,000,000 samples? So taking more samples should mean, the model can pass, it's more likely to pass, right? And yeah, so here's the metric. So with more samples, then the model has a higher likelihood of passing. And the larger so more samples means better performance. As you can see here on the y-axis, higher is better. More samples means better performance, And then this is all, the different lines show how many parameters does the model have. So more parameters means that the neural network model is bigger. That's the main thing. So the bigger the model is, also the higher the performance. So the best performing model is the one shown in purple here. That's the biggest model we have, which is 41 billion model. The rest are smaller, from 300 million to 100 and to 41 billion. 300 million is the smallest, 41 billion is the biggest model. So the bigger the model, the better the performance. Yes, and we also see the same trend, although the trend is better with this. So if we give them unlimited attempts per problem, so if, okay, we're going to sample 1 million samples from the model, we're going to submit them all, see if one of them passes, then the model does even better with that. Okay, and then, yes, so, and the solve rate is also improving, so performance is getting better if we use more models for training. If we use more computational resources for training the model. So yeah, so the x-axis shows how much compute does it take to train the model, and the more compute, then the better the performance in general. The curve is kind of going up, which means that more compute means better performance. And this is the training compute here. This is sampling compute. So how many samples? How many compute does it take to do the sampling? And the same thing. So more samples, more compute for sampling means better performance. Yeah, as we can see here. Right. So the key thing is that, okay, say we have 1 million samples from the model, right? We have 1 million samples from the model. And then the question is, how do we pick the 10 samples that we're going to submit? Right, so we have a lot of samples. We're going to pick which one are we going to submit? Which one is our best solution? Anyway, we have to pick 10 solutions from a pool of 1 million samples from the model. And then, right, so the way that AlphaCode does it is with something called clustering, because we want the 10 solutions to be as different from one another as possible, right? We don't want to submit the exact same program in those 10, which we want that to be, because the results are just going to be the same, right? If it's the same program, then program A and program B, they're the same, then they get the exact same output, which means that if they're right, then they're right. If they're wrong, then both are wrong. We don't want that. We want, if one is wrong, we want the other ones to be right. So what we want is that we want to pick samples that are as different as possible from one another. And then, yep, so we do some clustering in AlphaCode. So we use the model to predict the test inputs, and then we use these test inputs to the generated code samples. So we predict new test inputs, and then we're going to run our samples through this test input to produce the outputs. And then we have the output of each program. We're going to cluster them. And then, right, so we have their cluster. So cluster 1, the output is yes, for example. Cluster 2, the output is no. Cluster, yeah, and so on and so forth, right? And we're going to pick one code solution from each cluster, so that hopefully if one of them is wrong, then the other ones will be right, because they all produce different outputs anyway. So yeah, and then yeah, that's how we pick 10 solutions from 1 million samples. And hopefully those 10 are as different as possible, and we're just going to try those 10 samples on the output. And yeah, so how important is this clustering? So without this filtering step, so filtering means that we have the test cases, right? We're only going to pick programs that pass the test cases, so that's filtering. And if we don't do that, then performance is really bad. And if we don't do filtering, that's bad. If we do filtering, performance is a lot better. That's the green line here, which means we're only going to pick codes that can. We're only going to pick codes that pass the known test cases, basically. So it's a green line here. And then that's just doing filtering. And then if we do filtering and clustering, so this is the clustering that I mentioned earlier. If you combine filtering and clustering, we get this orange line here, which performs even better than just doing filtering, which is the green line here. So filtering and clustering gives us the best performance. And the blue line here is the upper bound of the performance, the pass it case. If we can submit all solutions and one of them gets it right, then the model is considered to be right. So this is the ceiling of the model performance in a way. Right, so what's the takeaway on this? So, well, so AlphaCode achieves the median human level performance in competitive programming, which is a really difficult problem. yeah, even I find competitive programming very difficult. And then the paradigm that we do is pre-training, and then we pre-train on GitHub, which is a very big data set, and all codes, and then we fine-tune on just competitive programming, which is smaller than GitHub, much smaller than GitHub, but it focuses just on competitive programming. And then we train the model, pre-train the model, fine-tune the model. The model is trained, and then we do sampling from the model, and then we do filtering and clustering to pick the best samples from the pool of samples that the model generated. So yeah, that's the gist of how AlphaCode works. And then yes, so the model does well on unseen problems because all the test sets are new problems. It's not the same problems that they've seen on the training set. Rather, they're really new problems. And the model does it in the way that does not copy from the training set. So in the way the model can generalize well. That's what we want in machine learning. A model that can do well in new problems, right? Yeah. So the bigger takeaways is that transformer neural network models, which is a type of deep learning model, they're very powerful priors in the sense that once we pre-train the model on GitHub, then once we pre-train on GitHub, then we can just fine tune on the small data set of just 10,000 examples, which is really not very big, right? It's a small enough data set. So once we pre-train it, then we only need a small data set to make the model specialize in this competitive programming example. Yeah, and then fine-tuning with only a small data set still results in amazing solutions if we have a model that's pre-trained on a large data set, which we got from GitHub in this case. Right, and there's many new opportunities. I mean, people complain that okay, deep learning is cool, but deep learning is a black box. We don't know why the model makes a particular prediction. Maybe what we should do is that have a deep learning model predict the program rather than directly predicting the solution. Because what's nice about it is that programs are completely interpretable. So if an AI write a program, you can see, right? You can look at the program, say this is the program, and then we can interpret, okay, so the model does this and that. And if something here is wrong, we can just fix it, right? And we can't do the same with with standard deep learning models. So maybe have an AI model, have the AI model write programs and have that program solve the solution in a way. So yeah, so that might be a more interpretable way of solving problems than just having a neural network model directly solve the problem, because we don't know why the neural network model makes a particular prediction. And yeah, so that's a bit of the AlphaCode. So I'll spend the next, say, 10 minutes, 10, 15 minutes on right, going back to the slides here. Right, so that's AlphaCode, which is one, I think, very exciting example of deep learning. Right, so okay, we've seen how how cool deep learning is with all the applications, including AlphaCode. But what's the frontiers and limitations of deep learning, right? Okay, they're good at certain things, but they're also not good at certain other things. So what they're not very good at is adversarial examples. So imagine we have like a photo tagging system. So we give the system a picture of a duck, and they predict correctly. All right, this picture is a duck. Good. And then what if we add some noise into the model, which is the noise is the one shown here, and then turns out that with just, and this is the result of the noise. So we combine this image with this noise. This is the result. And for a human, it looks exactly like a duck still, right? It doesn't make a difference. It's still a duck. But the model can change its predictions from, okay, that's a duck to, well, that's a horse, which is bad. So yes, so yes, the model is very sensitive to certain noises that for us humans, this noise doesn't make a difference, but for the model, this noise can really change the prediction of the model and make the model from performing well to performing badly due to the addition of this noise. And then current deep learning models, they still require a large amount of training data to do well. So imagine we want, okay, I'm going to make a chatbot, right? This machine learning models can generate very well. I'm going to make a chatbot. And then, well, for the model to do well, we might need lots of user dialogue data to train the model on. And the problem is that, well, not all companies have a lot of user dialogue data. If you're a company like Google, then maybe you do. But if you're a small medium enterprise, then maybe you don't have lots of dialogue data to train your model on, and that is a problem, which means that we need a lot of data, and not everyone has a lot of data, right? And some languages don't even have much data. So there's a lot of chatbot data set for English, but what about for Indonesian? What about for Japanese? What about for Sundanese? I mean, there's not much data at all for some of these languages. And then another problem is generality. So if we train the model on, okay, I'm going to train a sentiment analysis model on news data, and then I'm going to, okay, I train the model, and then I'm going to apply the same model to Twitter data in a way I want to know, okay, well, how do people on Twitter like this company, or do they not like this company? I want to know. I'm going to use my sentiment analysis model that's trained on news data, and that's not going to do very well because, well, the model does well on news, but if we do another domain, because Twitter data looks very different, right, from news data. On Twitter, people use a lot of slangs, on news data, it's mostly formal language. So this kind of domain mismatch from news to Twitter is going to make the machine learning model not perform very well. And this is bad also related to data imbalance, right? If we want to take scans of people, for example, X-ray scan, and then X-ray chest X-ray scan. I mean, most people don't have a particular condition, so most people don't have pneumonia. So most of our data sets will be without pneumonia, right? So 99% don't have pneumonia, maybe 1% have pneumonia. This is bad because it means that the AI can get 99% accuracy just by predicting not pneumonia for everyone, right? Because there's a class imbalance. I mean, they might just predict the dominant class, which is not pneumonia, which is bad. So yes, this is a problem for current models. And then, current deep learning models don't know what they don't know, in the sense that we need, if we give the model a particular prediction, we want to know, can you answer this or not, right? Because if you can't answer it, then it's time for us to get a human to intervene and solve it, right? And current models don't do this well, and our deep learning models are currently not very interpretable. We need to explain our decisions to decision makers, right? If we, for example, okay, and then we have a machine learning system that shows, all right, well, this person has pneumonia, and then a doctor would ask, why do you think that? And then the machine learning model would need to, well, you see that bit over there actually is an indication, a strong indication that that the patient is suffering from pneumonia, for example. But our current machine learning models don't really do that. They just say, okay, you have pneumonia and you don't. And for doctors, it's not very useful. Doctors want to know, why do you think this patient has pneumonia? Which part of the lungs indicates that they have pneumonia, for example? And that's the reporting bias as well. So, machine learning is trained on data. So imagine you're a company and you'd like to know what people think about your company. So you make an online survey, and then there's a bias in the data collection process, right? Because who are the people responding to surveys? So they will have internet connections. So you'll only get responses from people who already have internet connections. What about your customers who don't have internet connections? Then you can't really survey them online in a way. Then that's a bias in the data. You don't get data from your customers who don't have internet connections. And if someone asks me to do a survey and I don't know the brand, I'd likely say, no, I mean, I don't have anything to say. I don't know the brand, right? So that's another bias. So you only get responses from people who already know what the brand is. You're not going to get responses from people who don't know what the brand is, right? Because they don't know what to think of the brand. So yeah, that's another bias in the data. And then you'll likely get responses from people who already like filling in surveys. I, for once, don't like filling in surveys. So if you collect your data from surveys, you're not going to get data from me, most likely. So yeah. So that's a bias in the data, means that if you train the model on biases on biased data, then you're going to get then you're also going to get a biased model in the end. So that's a problem. And deep learning works well when there are historical data. So for example, right, so imagine during the early days of the COVID-19 dataset, right? A pandemic is rare in human history. There's not many pandemics in the past, thankfully. Right, so machine learning models are not going to be very good at predicting, okay, what's going to happen in a pandemic, because there's not much historical data around what happens in a pandemic. But humans, we can still tell, right? Okay, pandemic, what happens in a pandemic? Okay, well, people get sick, means that healthcare stocks will go up, hospitals will be full. And then, all right, what happens in a pandemic? There's going to be a lockdown, which means restaurants will not do very well. Probably concert venues will be empty, but food delivery companies will do well because, well, we can't go out. So what we do is just food deliveries, right? So And we know this not because there's historical data about what happens, but because we can reason and think about, if pandemic happens, this thing will happen. If that happens, the other thing will happen, and so on and so forth. And machine learning models are not very good at doing that at the moment. And deep learning models may contain biases derived from the data. So if we feed machine learning models, these are the great scientists of the past, they might learn that, okay, all the great scientists in the past were white males for the most part. And that's not true, right? I mean, there's female scientists, people of color, Asian scientists, black scientists. There's a lot of those these days. So we don't want the model to pick up the biases from the data in a way. And there's research that shows that facial recognition systems works very well for white males, 100% accuracy, but they work much less well for female people of color, for example, from 100% to less than 70%, which is a big drop in performance. So this is a big homework for the machine learning community, and there's a lot of people currently in the machine learning community working on addressing these issues in particular. So yes, it's an exciting area to tackle because we don't want the machine learning model to pick up the biases from the data. Okay, so that's what's not very good about deep learning, and I'll spend maybe the next 5 minutes saying about. So I've been working at DeepMind for the last 5 years, and what are my thoughts from working at DeepMind? So I'll spend some time on that. So I think one thing that's very good at DeepMind, and I know this is also true at Google, is that there is innovation. So they really care about innovation. So Alphabet, which is Google's parent company, they spent $26 billion on R&D, research and development, against a profit of 34 billion. So they spent almost as much on R&D as their entire profit for the entire year, which means that they care very much about innovating, right? So innovation is very much encouraged at all levels, and when they select people, it's one of the things they look for. So can you do good research? Can you find new things? Are you good at finding new things, trying out things? Do you have a good track record of succeeding and trying out new ideas? So that's one of the things that I really look for. How innovative are you? How good are you in doing research and trying out new ideas and having those ideas have an impact? Anyway, yes, Google in a way is doing very well in Google search, but they invest a lot in AI because they believe that AI is the future. They're not complacent. Okay, we're good at Google search. We're not going to do any more research. No, they spend a lot on R&D. I mean, they do well on Google search, and then they want to be the best in the world in AI. And then how can AI improve Google search? How can AI improve Google Translate? How can AI improve Gmail? With the auto suggestion feature, and so on and so forth. So so Google never stops innovating. I think that's one of the really good things about them. And then I think there's a balance between top-down and bottom-up innovation. So top-down means, okay, the company wants these things done, and they need people to do it. That's top-down. And bottom-up is that, say, I have an idea, I want to do it, I have an idea, and then I do it, and then, I do it without anyone kind of telling me what to do. And then if that's relevant for the company, then they're going to scale it up to entire kind of Google scale. So it's a balance between top down, we need these things done, and bottom up, which means relying on people having ideas, right? Okay, I just have an idea. I think this is a good idea, and I think that's relevant for Google. And with a large company like Google, then they can't just rely on top down innovation, right? Because I mean, there's a lot of people. So, and the leadership doesn't know 100% what's going on at the bottom, what the ideas are, what people are good at, what research areas are exciting. So they rely on a balance of top down and bottom up on people taking initiatives and then having ideas and trying them out. So that's one of the nice thing about working at DeepMind. Oops. And then also related to that, so there's two things about innovations, which is one is doing fundamental things better than everybody else. So how can we make better Google search, better Google Translate, for example? And the next thing is also doing high risk, high impact research that nobody has done before, something like AlphaCode. Can we use AI to design new medicines? Can we, design better chips? Computers rely on chips, right? How can we design better chips with AI, and so on and so forth? So I think DeepMind does both of those, improving existing things with AI and also doing really ambitious things that's high risk, high impact. They do a bit of both. And lastly, I'll talk a bit about my personal journey and in AI. So I've been in AI for the last maybe 9-10 years. So yeah, so what did I learn from that long journey? So how did I get involved with AI? Is that so I first learned to do a machine learning research project in natural language processing during my final year at ITB. I did my final year kind of research on AI and specifically natural language processing on the Indonesian language. So that's where I got started, and I thought this is really cool. I have to do more of this. I have to know more about machine learning afterwards, and then that desire took me into a lot of places. So after graduating, I went to University of Oxford, where I did my master's in computer science, specializing in AI. As you can see, this is the city of Oxford in England. And then after that, I did a research internship at NICE in Japan, which was a very beautiful place, as you can see from the pictures here. I learned how to do more research in NLP there, and then after that, I did a second master's. So I did my first master's in Oxford. I did a second master's at Carnegie Mellon in Pittsburgh in the United States. I did research in NLP again. I was funded by full scholarship to do a research project from the US government on NLP for low resource languages. I did that. And then, yeah, after that, I moved back to the UK, and then I'm now a researcher at DeepMind whilst completing my PhD at Oxford. And my study in Oxford is funded by UK government, yeah, on a scholarship from the UK government. And this is the Google office in London, which rains a lot, as you can see here in the picture. Right, so it's a long journey in machine learning in my case, and I'd like to talk a bit about now. If you look at this, you might think that yes, you might think that this is okay. Well, that sounded like a smooth sailing, right? And I can assure you that it wasn't a smooth sailing at all. So I want to talk a bit more about the failures because I think it's important to be more open with these things, right? Because doing machine learning isn't easy. I mean, being an expert in machine learning isn't easy, and I'd like you to know how my journey was. At least your journey will be different, but I'll share a bit of my experience here. So I did my master's in Oxford, as I mentioned, and then, well, at the time I applied to many other schools from ITB, but Oxford was the only place that I got to. Oxford is an excellent place, but there was the only place that I got to. And then, right, okay, I went to Oxford, and then I failed 2 of 7 classes during the masters, and one of which is in machine learning. So I had reasons at the time to maybe I want to do machine learning, but maybe I'm not good at it. Maybe I'm not cut out for it. Maybe maybe it's just not for me. So that I thought that at the time, but then I decided all right, I failed the class, and then well, let's just keep going, right? Let's just keep going, keep doing it, keep trying anyways, despite that. Right, so and then I did internship in Japan, and then right, so I wanted to really focus in to do machine learning research, and then I had so I had a gap year before finishing Oxford and going to CMU. There was kind of a 1-year gap between that, and I looked into how can I do machine learning research in this 1 year. Unfortunately, the only option at the time was that to do an unpaid research internship, and of course, no one likes to work unpaid, right? So yeah, but I did it anyway. I talked to my parents, can we do this? And they supported me, so I'm very thankful for my parents. Let's do this unpaid research internship because that was the only option available at the time. I did that research project for 5 months, and then my very first research paper submission, that's the output of this internship. I worked on it for 5 months full time. I put in a lot of effort on it. It got rejected from a conference with a score of 2.3 out of 5, which was quite a bad score, as you can imagine. If you, for papers to get accepted, we usually need 3.7 and above, and this was 2.3 out of 5 rather than 3.7 out of 5. So there's 3 reviewers, none of them liked it, and I worked on it 5 months, and this manuscript has not been accepted to a conference until today. So this was 7 years ago, but it's still not accepted until today. But I learned a lot during the research internship, but it just the output that I worked hard on just didn't end up being accepted anywhere, which was fine. And then I went to Carnegie Mellon, and then I almost didn't get to work with my first choice of advisor, and then I got rejected by all the other professors. So he was kind of pretty much my only choice. And then, but I managed to convince him, partly through luck. Yes, so that's that. So this was kind of an almost failure in a way. Yes, so right, so when I speak with you who are probably just starting out in machine learning, there's a few things that I would tell you, and I would tell my younger self as well if I can go back in time in a way. So the first thing I would tell my younger self is that technology is a really promising and impactful field, right? And AI is, I think, one very promising field of technology. But in practice, developing an expertise in AI is really hard. As you can imagine, I started 9 years ago, and I failed a lot of classes in machine learning because it was really difficult to get the mathematics right. And I spent 9 years already so far in AI, and there's so many things that I don't know, and so many people around me. I feel like, how do you know this? And how is it so easy for you to learn this thing? Well, for me, it's actually difficult to learn it. And yeah, I still feel that way after 9 years, and doing PhD at Oxford, working at DeepMind, I still feel that way pretty much every day because at DeepMind there's so many smart people, and I feel like a lot of people are smarter than me. And yeah, it took me a lot of time to really get used to machine learning, getting the basics right, and start doing research projects with a lot of people way smarter than me, I feel. And yeah, so what I would tell is that patience and persistence go a long way. You're not going to get it right the first time, and that's fine. Failing the classes is fine. Just learn from it and keep trying. At the beginning is the hardest. So yeah, well, the start of really getting the basics right in machine learning was the hardest for me, especially coming from Indonesia, going to the UK. That was really hard because in the UK was much more difficult. I feel the classes, and so my advice is to take the initiative and do as much self-study as possible. There's enough machine learning class material out there that you should take the initiative and do as much self-study as possible, and don't give up. And then communication skills are really important. So you might think at Google at DeepMind, then you'll spend most of your time coding, right? Because it's a very technical company. Now, my day at DeepMind, almost 50% of my time is spent communicating, which is meeting people, managing things, supervising interns, writing proposals, writing papers, presenting things. So in a very technical field, which is AI, in a very technical company, I spend almost half my time communicating. So just don't neglect the communication skills. You have to be able to sell your ideas. You have to be able to uh, convince people why this is an exciting project, right? Why this is important, what the impact would be. And my advice would be to learn to communicate to both a technical and non-technical audience. You should be able to, technical people, you should be able to communicate with technical people, because if you do machine learning, then you have to. But also don't forget how to communicate with non-technical people, because you have to sell what's your research about? Why is it exciting? Why is it important? And yeah, a lot of the people you talk to won't be technical. They won't know the details about what a transformer language model is, but you still have to be able to sell your research, your project, why it's exciting to them anyways. And yes, persistence is underrated. So believe in yourself, that's the first thing, and your goals. So if you think that's a worthy goal, then keep doing it. There'll be setbacks. Everyone has setbacks along the way, but me personally, I'm happy that I kept going, because if I stopped, when I failed the classes, if I stopped, then I wouldn't be where I am today, working at DeepMind doing cool things with AI. So I'm really happy that I kept going despite setbacks along the way. And the truth is that I needed a few lucky breaks along the way. So to get where I am today, I'd be the first to admit that there was a lot of luck involved, right? Yeah, so yeah, you'll need a lot of lucky breaks along the way. Because a lot of progress relies on external factors that are not due to you. For example, you apply to a place, maybe they just they don't have any opening, for example, in that particular year, or maybe there's just a better candidate in that year. If you had applied the year before, maybe you would have got it, but in that year there's stronger competition than usual. It's not you; it's just there's more competition, which is an external factor in a way. But luck favors those who are prepared and those who keep on trying. So if you don't get lucky the first time, try a second time, try the third time, and maybe one of those times you will get lucky. So yes, you'll need some luck, but luck favors those who are prepared and those who keep trying. And yes, so my final message here, it's my last slide, is that I do think that the next wave of technological advances, especially coming from AI, should benefit everyone, and not just the few people who live in developed countries, for example. So yeah, for example, problems like fighting climate change, maybe detecting forest fires, right? Indonesia, we every year we hear the news about, oh, there's forest fires this year going on, or illegal logging, or all those things. These are problems that I think AI should be able to solve these things, right? And it's good to start local, with the Indonesian community. I'm always happy to collaborate with the Indonesian research community on how we can design AI systems that can solve problems that impact people's lives, not just in the UK or in the US or in Europe, but also in developing countries like Indonesia. Yeah. Okay, my final message is that whenever your journey takes you, I have two advice. So one is that aim high, so you don't get satisfied quickly. So in the sense that my aim personally was that I wanted to do my best work in machine learning, and I wanted to work with the very best people in machine learning, and that's why I moved countries so much, right? From Indonesia to the UK, to Japan, to the US, to the UK again. All this to reach my goal of I want to work with the best people, and I want to really be the best in machine learning. I want to be an expert in machine learning, and I'll do anything to get there. So do aim high, and don't be afraid to aim high, and don't be afraid of failures. If you aim high, then there's a high likelihood of failure. That's how it is. But aim high anyway. Just don't be don't so don't be afraid to dream basically to dream. Okay, to have a worthy goal. A worthy goal is not going to be easy, but I think you should aim high anyway. And the second is that make a difference. So don't just think about yourself, and that's one of the reasons why I'm here talking to you today. One of the reasons that I like sharing knowledge. That's the first reason, and the second reason is that I know how hard it is for an Indonesian to get into machine learning. It's difficult, right? There's a lot of barriers, and that's why this is my way of giving back to the community. Is that I want to help contribute to educate the next generation of researchers in underrepresented communities in machine learning, including in Indonesia. So that's one way of giving back to the community and making a difference. And I think here you have a unique opportunity to do so. So don't just think about yourself, but also think about other people. How can you help other people? Maybe you can write down what you learn, make a blog about, okay, what I learned in the Bangkit program. Or maybe you can create tutorials, okay, machine learning, deep learning tutorials in Indonesian, for example, because not everyone can read English, right? And all the deep learning books are in English. So maybe you can help make tutorials or write blogs about machine learning in Indonesian, so that you can teach the next generation of people. That's how we build a community. From one generation to another, we have to pass on the knowledge and build a community. Maybe you can mentor younger students, create sharing sessions, or give guest lectures at university, or present your capstone project in other places. This is my capstone project, and this is what I learned. This is how to do it. Tell people about the steps. So there's so many things that we can do, even small things, to make a difference, and build underrepresented machine learning communities, so that the next wave of AI advances will hopefully benefit everyone in the world, including people in Indonesia. So that is it from me. I think I'm a bit over time, but we have 40 minutes for questions, hopefully.
All right. Thank you, Kak Adi. Very very inspiring for us. And from the overview of machine learning, artificial intelligence into the DeepMind, AlphaCode, and the challenge. The next is the challenges to build a model, and the last is your journey that inspire us to be like you. Thank you so much, Kadi, for your presentation, for your sessions, and we can go to the Q&A session, and we see there are many questions for you. Let's start from this Muhammad Irfan Shanif Rusdi. Recently, there is many news about Lambda. From your opinion, is it really just large language models chatbot, or could it become sentient?
Yeah, I think it's a philosophical question. So I think it's hard to answer because one is that I don't think that sentience is well defined. So what does it mean for something to be sentient, right? What are the criteria? I think without defining what sentience is exactly, then it's hard to say. But I mean, my personal opinion, I mean, I know sentience is ill-defined, but I don't think it's sentient. I mean, knowing how these models are trained, how these models are trained, I think we train them on data, and then I don't think they are sentient. I think they are statistical pattern matching models of data. Yes, so and of course, I think this is a topic that has come over and over again. So I think I forgot when in the 50s or the 60s, someone made the earliest version of a chatbot, maybe called Eliza. I don't know if you've heard about Eliza. And then yeah, it really was a rule-based system. It wasn't even a machine learning model. Rule-based system. Someone says this, you reply this. Someone says this, you reply this. So just a set of rules, and then some people develop kind of attachments to that. So I think as humans, we have a tendency to attribute sentience or when to machines, even when it's just a simple rule-based system, not even any machine learning. Then people already felt the same way back then. So I think it's another case of that. So how these models are trained, I don't think they are sentient in the sense that they have an agency or they're self-conscious in that sense. Although I think I can't really answer that question without us agreeing on a definition of what sentience is exactly. But that's my personal thought of it.
Right. Muhammad Irfan, hope the answer will receive for you. The next question is Gabriel Asael Tarigan. I still have to wrap my head around a few things. Were there any projects that were deemed impossible to do by DeepMind?
Well, I think there are many things we can't do yet with AI. So AlphaCode is at median human performance, for example. Then the next question is, how can we make superhuman AI on competitive programming, right? That's one. And I think competitive programming is only one domain. So it's only one specialized domain. I mean, if we want these systems to be useful in real world applications, eventually we have to move beyond competitive programming to more open-ended domains. So, for example, something like AI creating a website based on a human specification. And I think one thing that's still missing is interaction, in the sense that right. I mean, I think right now it's one way, right? Okay, we have a specification, and then AlphaCode does the coding, right? That's it. They have the output. But I think for what we need is more in human interaction, in the sense that, I mean, in the real world, I mean, the program specification is often ill-defined in the sense that, okay, I ask the model, okay, can you build me a website? And then I want a website with my homepage, publication page, my CV, and my link to my LinkedIn. And then the model should be able to ask questions and ask questions in a way, in the sense that, okay, well, what background do you want? Or where do you want the website hosted? And then I think interaction with AI should in future be interactive rather than just one way. I want this, and then the model does the coding, that's the output. But rather, I think model should be able to ask for clarifications and refine it. And then they have a website for me, for example, and then I say, I don't like the background color. Can you change it? And then they change it. And so I think human AI interaction should be interactive rather than kind of one way. And I think it's still I think we're still a long way from that. And that's one underlying assumption in a lot of these breakthroughs, is that this AI does things pretty much on their own based on human specification. But I think in the end, the real homework for us is how do we make AI and humans to work together, rather than AI replacing humans, but rather AI working together with humans and making our lives easier. And I think the way to do that is through interaction. Maybe they can give a template for me, a website template, and then I work from that. So rather than AI replacing humans, but rather AI making our lives easier. Something like GitHub Copilot, I think is one step towards that. I think AI should augment humans rather than replace humans, and I think we still have a long way there. Yeah.
Yeah. Gabriel, maybe in my opinion, this maybe AI and human will collaborate together, right, Kak Adi? And there's still a lot of step to collaborate human and AI, because there are so many controversy for AI.
Mhm.
Yeah. Thank you, Gabriel. Next question from Muhammad Irfan again. Can you give the tips and tricks to minimize delay and computing power needed to deploy and serve language model or big model in cloud?
Mhm. Um, Yeah, I think it's an important research question because at the moment, models like GPT-3, they're so big, right? I mean, they're inaccessible by, people in academic institutions, not even just in Indonesia, but I've heard my friends and, they're doing their PhD in the US and they're saying there's all these large models, but we can't use them. So I think it's a problem, this inaccessibility of large models for a large number of people. It's a big problem, and I think there are uh, there's a lot of research questions revolving around that, which is how can we compress this model? For example, we have a big model that has 10 billion parameters. Can we have a smaller model that just has 1 billion parameter but can perform almost as well as the 10 billion parameter model? And it's an active research question. Some techniques include knowledge distillation. You might have heard about distilled BERT. BERT model is big, right? And pretty slow if you don't run them on GPU. There's kind of distilled BERT or tiny BERT. So they aim to make the BERT model smaller, but performing almost as well. I mean, it's not going to be exactly as well because I mean there's a size difference. But how can we do kind of model compression techniques like knowledge distillation, model pruning, model quantization, those techniques, how can we use them to make compress this large models into smaller models in a way that retains most of the performance gains of model size? I think is yeah, it's an interesting question, and I think people in academia should maybe at DeepMind is less of a problem because we have a lot of compute, but yeah, in the end, we don't want just people like DeepMind, Google, Meta, OpenAI, Amazon to have access to this model. So we want everyone as much as possible to have access to this model. So it's very much an open research question. I think. Yeah, sorry, I don't have a good answer, but there are some previous attempts to that on even models like BERT, like tiny BERT, distilled BERT. So you might want to check into that. Yeah.
Yeah, maybe you can try that solution from Kadi. uh,
Mhm.
well, you can. I think it's based on your model. Maybe it's NLP or computer vision.
Mhm.
It's depends on your model. Before we going to the next question, if you guys have any question, feel free to put them in the chat box. Okay. Next question. The moment you start your journey from Andro Aprila, what kind of portfolio, uh, based on your experience, to enter this research career path? Uh,
Mhm.
he want to ask about what kind of portfolio you have made before.
Mhm. Yeah. Yes. So I think for my portfolio, when I started, I didn't know much about machine learning. I took some, text mining class. Yeah, but at the time there weren't too many class offerings at ITB on machine learning, and then I just jumped in with with my final year research project, proyek skripsi, di bidang NLP waktu itu. Yeah, so I did that. Yeah, that was my portfolio pretty much, and then yeah. So, but I think nowadays it's different in the sense that machine learning is much more mainstream in a way, and there's many ways of building portfolio. One is that you can do the same thing, do your final year research project on machine learning related topic. That's one way of building portfolio. Second is that you can get certifications maybe from like Coursera. There's machine learning classes. There you can join the Bangkit program as you already did and do your capstone projects. The capstone project should go to your CV, right? I mean that's a part of your portfolio, especially if it's machine learning related. You can do internships in industry, maybe like data scientist intern roles in industry. You can try machine learning firsthand, what works, what doesn't work for a particular problem. Yeah, you can do internships on a data science related role or a machine learning related role. You can do Kaggle. I mean, if you perform well on Kaggle, that should definitely go on your CV because it's competitive, right? That's machine learning in practice right there. There's many ways of building a portfolio, but I think the question is about research career path uh, specifically. So I think if for research career path, I think it's good to do some kind of mini research projects earlier. For example, Bangkit capstone project can be I don't know, making a machine learning model for garbage detection. Is this garbage recyclable or is it not recyclable? That's a machine learning research project. In a way, maybe if you want to do research, I'd recommend doing a write-up. So, right, not just doing the project, but also writing a paper based on your findings, because in the research community, that's how we share ideas, is through research papers. So I'd say that don't just do the project. It's important to do the project, but also engage with the research process, the peer review process, the publication process. So yeah, maybe you can talk about the professors at your university. Because professors have to publish, right, usually, so they know how to do the publication process. Ask them to guide you, ask them for advice, take the initiative. So yeah, if you want to do research specifically, I think doing research projects in particular would be helpful to break the barrier into the research community and do a master's or a PhD later on.
Yeah, okay. Andro, that's the answer. You may have to create your own mini research and try to write down the research on the paper. Okay, next question from Pandia Atalah Erlambang. What's the next big thing or general trend for AI in natural language processing? So far, we have seen impressive text generation with GPT-3 and early natural chatbot with Lambda.
Yeah, so I think one is efficient modeling. As I've mentioned, I think efficiency is a big homework for the field, because one, the model is not accessible, and then yeah, I mean, it takes so much compute already, and I don't think we can rely on hardware advances for the next. Okay, we're gonna scale compute. Now we have 100 billion parameters. I don't think it's easy to go to 1 trillion parameters or 10 trillion parameters, right? So I think, how can we make these models more efficient to train? Maybe, I don't know, rather than having to train for 30 days, maybe we can train for 10 days, but have the model still perform quite as well. And there's many ways of doing that. For example, having using our prior knowledge to guide the model. Yeah, so for example, I mean, if we train a big model, usually we train a smaller model first, right? We train a smaller model. Does it work or not? If it works, then we train a bigger model. But maybe, yeah, but then we train the big model from scratch again, right? Okay, we train a smaller model to test a proof of concept, and then does it work? If it works, then we train a larger model, but we train the larger model from scratch. But maybe what we should do is that, okay, we have this smaller model that works, but so that the larger model can build on top of the smaller model instead. So does it make, so they don't have to learn everything from scratch again, right? So they can learn from yeah, they should be able to learn from this from this smaller model, so that they don't have to learn everything from scratch. So rather than learning everything from scratch, I think it'd be interesting if we can make the model more efficient by leveraging I don't know, smaller models to make the larger models train faster, for example. Rather than, so I think that, so in short, I think the trend is not to train things from scratch anymore, but rather building up on top of other things so that they can accelerate the training of the large models. Because right now it takes so much compute to do that. That's one. I think another is, I think that's exciting, is reasoning. So I think I do think that the natural language to code space is really interesting. AlphaCode is one of that, but I think there's a lot of, it's remarkable, but there's a lot of room to improve on. They're now at their median human performance. So I think if we can, make machines that can, code better. So input is natural language, output is code. I think that's really exciting, and I think that's still challenging for current large language models. I mean, they do better than I would expect, but still, I think there's still a lot of work to be done to get there. So I think reasoning and programming would be another exciting thing to do. And I think another thing in NLP is to go multi-model. So not just, usually large language models just take text input, right? But what if we do multi-model in such that they can take text and image as input? I think, for example, you take a picture of something and then you ask, okay, what is this? What is this? Or I take a picture of a food, for example, and then the system can generate natural language descriptions of, okay, this food is this, it has this many calories, the ingredients are this, and this, right? So I don't think, I mean, humans don't just talk. I mean, we see as well, we hear things. So eventually, if we'd like to make AI that can interact well with humans in the real world, they can't just generate text, but rather they also have to see and interact with humans in a way. And another thing is interaction, as I've mentioned before. Now it's just one. I think dialogue systems are the exceptions, but large language models are still, one-way street, right? You give them a text, they continue that text, right? So it's a one-way street. But I think, eventually, I think they have to be able to clarify. Okay, what I asked them to do something, and then they clarify. Oh, what do you mean by doing that? Do you want me to do A, or do you want me to do B? And then I want to do A, and then okay, well, all right, okay, sounds good. Yeah. So I think the trend will be towards more kind of chatbot style rather than standard language models. So I think the style is towards more interactive, better interactive models that can help humans do everyday tasks. Right? Booking a restaurant would be one. So I think interaction will be. It will have to come to play at some point.
Okay, Pandya, that's the answer. Okay, I think there's ah there's another question from Muhammad Irfan. Is there any resources that I can read or code samples to make different size of language models? For example, some base language models have light or distill version. How did you guys doing that?
Mhm. Yeah, so I think they detail the technique in the paper. So if you go into tiny bird, for example, that's one paper, or distill bird, they outline the technique used. But basically, what they do is that they have the large bird model, for example, the standard size bird model that's large and slow, and then they create a new smaller bird model, so same architecture as the bird model, but much smaller in terms of model size. And then they use this large bird model to teach their small bird model. So so there's a teaching dynamic in play there, which is okay. Large teaching model is gonna teach the small student model such that the small student model knows how to behave just like the large teacher model, but despite not having the same number of parameters as the teacher model. So it's called knowledge distillation, that technique.
Yeah, it depends on the situation, right? The
Mhm.
smaller model. Okay, Muhammad Irfan, thank you for the question. Another question again from Muhammad Irfan. Since the transformer-based model became popular, many NLP model is built for specific tasks. Can we combine many specific task model into one multitask model?
Yes, I think so. So that's I think what language models do is that large scale language models like GPT-3 they can do. We train them on lots and lots of data, and the model size is really big, and then they can do multiple tasks at once. So, for example, they can summarize text, they can translate from one language to another. They can even do some kind of programming. So I think large language models like GPT-3, uh, yeah, they can do the kind of general purpose learners in a way. So I think GPT-3 paper has more details on that. So I recommend if you'd like to know what GPT-3 was able to do, then I think the paper outlined that. And there's a lot of other language models since, right? Google has the Palm language model that's bigger than GPT-3. DeepMind has the Gopher, and Chinchilla language models that's even bigger. And all these models are kind of multitask learners in a way. One single language model that can do multiple things at once.
Yeah, so it is possible into one multitask model.
Mhm.
Okay, next question from Andro Aprila. Elaborating to the slide that said in deep learning lacking of data is a big problem. In your experience, how good synthesized data set based on online condition could generalize the model better?
So synthesized, I don't mean synthesized data set based on online condition. Yeah, sorry, I'm not too sure what it means here.
Maybe Andro can explain again. what the question?
Yeah. Oh, good synthesized. Yeah, just that bit that I don't understand. Okay, I think she's clarifying.
I mean, we will recreate a dataset based on real condition.
Uh-huh. So you mean have the model generate the data, regenerate the data, so have model generate the data, something like that?
Maybe he means that the dataset is collected online
Mm-hmm.
or real time collected.
Yeah. Mm-hmm. Mm-hmm. Yeah, I think yeah, I mean, when it's a low resource data scenario, then we should get data from every source we can get. And in the case of language models, that usually involves scraping the website. You know, for example, if we want to make a large language model for Indonesian, then we would have we would scrape Wikipedia, Common Crawl, so we would scrape the internet for data. Yeah, so a lot of our data sets are actually scraped online in a way. Sometimes we need to label them. I mean, if you want to create an image classification system, then we would need to yeah, we would need to scrape the data and then label it, right? Because if we want to do supervised learning, so yeah, so yeah, I think we should definitely scrape data from online, but be careful, you know, such that the data sets should not leak personal information. For example, if it's someone's phone number, then maybe we should include that in the training data because it's someone's privacy, right? Yeah, so yeah, we can scrape data online, but then yeah, just be careful. We should filter out harmful material. So, for example, if someone is saying offensive things about a certain group of people, then we should not include that in the training data set, right? So we shouldn't just I'm going to collect all the data, use that for training, but rather we should do some sort of filtering to make sure that our model isn't trained on bad data. In a way.
So yeah, yes, it's possible because but you have to be careful with the data set. Okay, I think that's enough for the question and answer. Thank you, Kak Adi, for your answer, and thank you all of you guys for asking Kak Adi about, especially in natural language processing model. And we we have to end this session. Before we end this session, maybe Kak Adi will get a final speech for us, and maybe Kak Adi can share the maybe your LinkedIn or maybe your contact to contact with us.
Mm-hmm. Yeah. Okay. Yeah. Well, thanks all for the great questions, and I enjoyed the discussion. Yeah, it's always good to see many questions, and yeah, it's fun. Yeah. So thank you again for listening. I know it's a long talk, so yeah, thank you for staying all the way. And yeah, so as I mentioned before, my final message is that, well, first thing is that we should aim high, in the sense that, we are good enough. I mean, I did matter in Indonesia, and there were times when I thought, okay, maybe I'm not cut out for this, right? Maybe it's machine learning is too difficult to do, and I think, yeah, one thing I want you to keep in mind is that we are good enough. We are good enough, and we can do it. I mean, but we have to dream high first, and there's going to be a lot of work. I mean, it's going to be difficult. But I do truly believe that machine learning and AI will be the next transformative technologies in the next years. I mean, we can save people's lives, design new medicines, or make information more accessible to people. Something like translation system that makes information more accessible to people, right? I mean, we take it for granted, but even making better translation systems, it's something that can have a high impact. Or I know people who are working on image captioning. So given an image, they have to come up with a caption, and that can help visually impaired people, blind people. They can't see, but maybe they can point their camera at a scene, and then we can have AI help them cross the street, for example, saying, okay, the street is now free, or okay, well, this object that's right in front is a milk, something like that. So I do really believe that AI will have a transformative impact, and I really believe that we're just in the beginning. So it is really important for me that more people from underrepresented community be involved in AI, and that's one of the reasons why I'm really happy to see the Bangkit program running, because we need more people, including ones from people from Indonesia, because their local problems the best, right? The problems with garbage, with traffic, with forest fires. So and we should start working to solve them. So so that's the first one is aim high, and then aim high and dream big. I mean, don't be afraid to dream, and don't give up easily. I mean, it is difficult. I mean, anything worthwhile is going to be difficult, right? If it's easy, then likely it's if it's worthwhile, then it's likely to be difficult. But don't give up. Believe in yourself. Believe that you can do it. And lastly, don't forget to make a difference. I mean, don't just think about yourself. That's a lot of homework that we can do. We don't have machine learning resources in the Indonesian language. For example, we don't have many of those. We don't have many data sets, machine learning data sets in the Indonesian language. So if you make a data set, then please open source them, right? If you make a code that does something, please open source them so that other people can build on top of your work. That's how we build a community. We give back. So don't forget that. And I really look forward to see the great things you do in the years to come. So I'm really excited for your journey, and I wish you the best of luck, whatever comes next.
Okay, thank you, Kak Adi. So don't forget, just be brave, dream high, and don't forget to innovate with small problems in Indonesia. Thank you, Kak Adi. Thank you, guys, for joining us in this session. And don't forget to fill the attendance form on the description below. And see you guys another Bangkit guest speaker session. Bye.
Thank you, everyone.